a negative here, I want to separate that, okay, and simplify. So e to the negative 3x squared equals the sum from n equals 0 to infinity of negative 3 to the n times x squared to the n, which is x to the 2n, over n factorial. And then I have x to the 4th times it, so now I just multiply each side by x to the 4th. So I have x to the 4th times the series from n equals 0 to infinity. I have negative 3 to the n times x to the 2n over n factorial. And so now, okay, I want to simplify that because I just wrote x twice and I don't want to do that. Okay, so I want to multiply. I'm going to multiply that inside. So I have negative 3 to the n. What happens when I multiply x to the 4th and x to the 2n? What am I going to do? Right, add exponent, so I have x to the 2n plus 4 over n factorial. Any questions? All right, so then let's do the next example. Shortcut. Okay, we were able to know the Maclaurin series for e to the x and then plug in from there. Okay, however, this one we can't do this because this one is centered around x equals negative 4. So if I have a center other than 0, I cannot use a shortcut. So in that case, I would have to do the 4 steps. Okay, I have to find the derivatives, evaluate, and then plug in. Can't use shortcut. Since center is not equal to 0. Okay, so instead, I do this other method where I have the 4 steps. The first step, I need to find the derivatives. So this is the same method that I did yesterday, the first example of Taylor and Maclaurin series. Okay? So I find the derivatives. First, I always have to write f out, okay? Otherwise, I'm going to get the answer wrong. So I have f equals e to the negative x. Then I take the derivative. So what's the derivative of e to the negative x? Right, negative e to the negative x. F double prime? Right, because I bring down the negative and the 2 negatives cancel. So I have e to the negative x. F triple prime is negative e to the negative x, and this just continues on forever, alternating between the 2. So step 2, evaluate at the center, which in this case is x equals negative 4. Okay, so now I plug negative 4 into f and all its derivatives. So I have f of negative 4 is e to the negative 4, which is just e to the 4th. Then I find f prime. Okay, so I have negative e to the negative 4, so I just have negative e to the 4th. F double prime of negative 4. Okay, I plug in negative 4, and I get e to the negative 4, which is e to the 4th. And that makes sense, because f and f double prime are the same, so when I evaluate them at negative 4, they should also be the same. And then f triple prime of negative 4 is just negative Questions? Yes.
The pattern's always going to be like for sequences long, if not sequences. You know what I mean?
Like I found 4 of them?
Yeah, like the pattern always show up, but what you have to do, like sometimes go to like 6 or 8.
Yeah, so good question. So in the next example, you're going to see that I'm going to go to more than that. Okay, so generally speaking, this is a good amount. However, when we eventually find the pattern, sometimes we'll be able to find the pattern, and sometimes we won't. And if we can't find the pattern with just up to derivative 3, then we have to keep going. So it's kind of just like on your own judgment. You just do however many until you can find the pattern. Okay? But 3 up to the 3rd derivative is an average amount. Any other questions? Okay, so step 3, plug in. So I write out the formula for the Taylor series, okay, centered around x equals -4. So my first term is f of a, okay, and a is the center, and in this case the center is -4. Okay, so I have f of -4 plus f prime of a, which is f prime of -4, over 1 factorial times x minus the center, so I have x minus -4. Okay, and then I have f double prime of -4 over 2 factorial times x minus -4 squared, and plus f triple prime -4 over 3 factorial times x minus -4 3/3. And then it keeps going on forever. Okay, so that's the formula for the Taylor series, centered around x equals -4. This is a definition. The only thing that I did differently was plug -4 into a, because a is the center, -4 is the center here. So now I evaluate, okay? I plug all these into my formula, so I have f of x equals f of -4, which is e to the 4th, plus f prime, which was -e to the 4th, over 1 factorial times x plus 4. Then I have f double prime as e to the 4th over 2 factorial times x plus 4 squared. And then I have f triple prime negative e to the 4th over 3 factorial times x plus 4 to the 3rd, and so on. And I just simplified the 2 negatives that cancels to a positive. Any questions? So then step 4, find pattern. So f of x, which in this case was e to the -x, okay, can be expressed as the following Taylor series, with sum from n equals 0 to infinity, okay? Now we plug in something in, plug the pattern based on this. So what do we know? What's one thing we notice about this pattern? Spiro.
It's -1 to the n.
Right, -1 to the n because the sign is alternating. Something else?
N factorials on the bottom.
Okay, good. N factorials on the bottom. We just increase by 1 when we're taking the factorial. Spiro?
It's e to the 4th.
Right, e to the 4th is in every single term.
X plus 4 per n.
X plus 4 to the n. Good. Okay, because x plus 4 is being raised to an exponent that increases by 1 every time. Okay? And so that's our answer. So function e to the -x can be expressed by this Taylor series or power